Good afternoon all. New printed circuit boards from JLCPCB. These are my EVSE circuit boards. They're quite nicely packed, so let's get them open. So this board will replace this board, which was in the EVSE that I bought. Electric vehicle supply equipment. Right, get the shrink wrap off. And they appear to be wrapped individually, and that's because they do have a very small number of surface mount components on them, which I had put on by the SMT assembly service, of course, as I would. So I had 5 of these made, just because that's kind of the minimum quantity. I only need 1 for the moment. So I think what I'll do to start with is just see if a few basic items fit on here. So let's start with the fuse holder. Now this is the one I did in my recent post bag video, the BLX-A fuse holder. But there's actually another one in here, which is this, because I recently put an order into CPC Farnell, and I got some of these fuse holders which appear to be very similar and have a similar footprint. So let's try them both. And yes, the BLX-A one fits rather nicely in there. Here are my tracks, which I'm going to run tin copper wire along to enhance the current carrying capability of these. This is live up here, which goes through the relay to live going out to the car. This is live coming in from mains. This is neutral down here, also goes through another relay out to the car. And the fuse goes between live and the live side of my power supply, which sits there, which is the 12 volt power supply from mains down to 12 volts DC. So that fits fine, and it's got these little wiggly legs to make it sit in there. This one hasn't got wiggly legs, but it looks like the pitch is going to be the same. Yes, that's absolutely fine. It doesn't stay in, that'll fall out, but yeah, so both of those fit. Now I also have some relays. I don't have the Hongfa relays yet, but at CPC I found these Omron relays, which also have these spade terminals on the top. So let's get these out. Very nice shiny copper color on these top spade terminals. So this must have become a popular relay size because the footprint looks identical. Let's give that a try. Oh yes, that fits rather well in there. So yes, the Omron, whatever that relay is, fits in here. But also I used the footprint from the Hongfa. So that must be a standard layout. So the 2 relays will sit in here. Now I'm not entirely sure whether I'm going to be able to use these relays, because they're probably too tall for the box that I've got, but they'll go in like that nonetheless. Very nice. Also from CPC I bought these. Now these are these barrier terminal strips. I think these are rated at 30 amps. They're quite high current. But they only had the 6-way. They listed 4-way, 6-way, and more ways than that, but they only actually had these 2 in stock. So I bought the entire stock of barrier terminal strips, which is just these 2. So what I'm planning to do is actually saw these down to the 3-way that I need, which goes at this end, and the 4-way that I need there. Now I have also put these alternative footprints on here for 8.5mm pitch spacing barrier terminal strips. These are 9.5mm pitch spacing. Let's see if they fit. Now it's not going to be an exact sort of fit because I've got 2 extra ways there, but yeah, that does appear to fit across the pitch of there. So that also looks quite promising. I was playing with one of these the other day, I think it's this one, and I dug out this end piece because I'm going to have to take some of these out and saw this down for my 4-way and my 3-way, which are going to be made from 2 6-ways. Let's have a look at the little insert on there. So I'll take the screw out first, and then I'll try and dig out. I have dug this out actually, which is why it's not sitting completely flat in there. But you've got to sort of lever it out from both sides. Well, I'll work on that for a moment. And there it is, and you can see how it works. It's just a single piece construction. These barothermal strips have the pins running down the center, so there's a little offset on there. And then the shape of this has these barbs which sit in the plastic molding and hold this in place so it doesn't fall out. So yeah, it should be relatively easy to pull a couple of these out, get a saw in there, saw it off, and then I've got my 4-way and my 3-way. Incidentally, if you saw these cuts here, I wasn't going to put cuts on because I managed to keep my spacings between all the live and even the neutral lines and everything else sort of in excess of about 5mm for creepage, and that should be adequate. But right at the last minute I thought I'll just put a couple of these cuts in, because all you do is you place a track and then you right click it and you say convert to board cutout. So I put them in. They're probably not very appropriate. They are around the live terminals of this relay, but I just wanted to see what they look like, and they look like that. Holes in the board. What are the surface mount components? Well, very little actually. Anti-back EMF diodes for each of the 2 relays. There's a footprint for a capacitor there which prevents the relays chattering. A couple of NPN transistors to act as drivers for these 2 relays. I hope they're man enough for the job, they should be. And some resistors there on the bases of these 2 transistors, and another resistor which pulls up to 12 volts, plus 12 volts. So when I apply 12 volts to this board, I'll probably just poke it. Well, I might actually do it on here because I've put some runouts here for 12 volts. This is my prototyping area for CMOS logic chips and comparators, which are all on a 0.1 inch pitch matrix. So I'll put 12 volts in here, 0 volts in here, and the relay should pull in immediately because these 2 base resistors are then pulled up through a 10k to plus 12 volts, so they should turn on, and then it's the job of whatever's connected to this line, which runs across here through these pads, and I think through this one, yeah, relays, there it is. All these holes here are linked on the bottom, and so I can drive the relays through whichever pad happens to be nearest to my prototype circuitry. When you pull that down, of course, then these relays will turn off. That's the theory anyway. Now, one other thing I've got is this little power supply. So this is 2 40 volts in, actually probably a range of voltages in, and it's 12 volts at 0.25 amps, so quarter of an amp, that's 3 watts out. And although the datasheet for this said it would be nice if you had a common mode choke and a class X capacitor and a MOV and all that stuff, I haven't bothered. Thank you to the people who in the comments said, don't worry, it'll still work. And I've just put that straight across to the mains with the fuse. So let's just see whether that fits in its footprint. And it does. So that's pretty good. I'll probably leave this off initially and just provide 12 volts to this board through some other means, just for testing the relays and building the initial circuitry that runs off 12 volts. But that all looks good. Now there's one other thing I bought from eBay, which are these, and they are low profile. They're called chicken claw or something, I think. I can't quite remember the name, but they're the connectors that will fit on here, and I wanted the lowest profile ones that you could get. Now these I think would have to be soldered. They do come with these little caps. So I think these would have to be soldered. Doesn't look like you could successfully crimp that in any useful way. So I'll probably just squeeze these closed, solder wires on, and then see whether the height of all this fits in that box, but I very much doubt it. Now the next issue is, will this board fit in the original box, which is here? I'm obviously not going to connect up to the LED and TFT display in this unit. I'm not going to use that. So that's all the gubbins that I'm not going to use. They're covered by this. So all I'm really checking here is that I've got my hole spacings correct. Let's have a look. So these are the screws that go in and hold the PCB in place. So let's put a couple of those in. The distance between these holes just didn't appear to be a standard value, but it's quite hard measuring these, even if you've got calipers like these. It's actually quite difficult to get these points in the centers of the holes and get a meaningful reading. So I just kind of winged it, and I rounded these numbers up to numbers that seemed more sensible than the ones I measured. It doesn't really matter too much, and if there's an issue, I can just file these holes out a little bit. But let's see if this thing fits. Well, the first thing is, there isn't a very loose fit of that screw in there. It's a bit of an interference fit, so I might just file these out a little bit, in which case then it will fit. Because the problem is, with these being tight in the PCB, I can't feel my way into the threads in here, and I don't want to cross thread these because that just rips all the plastic out. So let's get these loose, and then I can feel my way into these threads. Yes, if I make a Mark II of this board, which I might, I'll definitely make these bigger. I don't remember actually measuring this at all. I think I just eyeballed it and thought 4mm, that sounds about right. Okay, well, I've filed these out probably to about 5mm now, and I think 5mm probably would have been better. Yeah, my NAS round numbers, I think I did 70mm across there. The board itself is 80mm. They're slightly out, but if I file these out so they're a good diameter, this will fit fine. So not too concerned about this, but yes, should have made those a bit bigger. Yeah, so the board's in. Now these two cables I'll probably disconnect at the other end because they're just going to get in my way, and as I say, I'm not using them. I slightly rearranged the order of these three wires. I put protective earth in the middle between live at the top and neutral at the bottom. I think in the other board it's different. Yeah, PE is on the end and they've got live and neutral bunched together. Didn't particularly like that, so I've moved PE to the middle, but those are in a pretty good place. These wires do sit on top of my prototyping area, but yes, I've come to the conclusion that this box is not actually ideal, because laying this board out, you've got mains coming in one end, mains coming out the other, relays either side, and then you're having to try and fit all your low voltage stuff in the middle of all this mains. I think it'd be far better if the cables both came in from one side, mains was all at the bottom and low voltage stuff was all at the top. So I may just put this EVSE back together again with its original board after I've done all my experiments. This won't be for a while. I'll carry on with this for a while and sort of come up with a rearranged design. But for the moment, of course, I'm going to use these prototyping boards. And yes, I'll be building the CMOS logic and the comparators, circuitry and transistors and bits and pieces, good old-fashioned electronics in this prototyping area to get my very primitive version 1 EVSE to actually function. So like I say, these wires are a little bit in my way. I'm just going to ease these plugs out of their sockets. You're not really meant to pull on the wires, are you? But it's so difficult to pull on the plug itself. And perhaps it isn't. There we are. They're out of the way. So happy with my PCBs I am. I've widened these holes sufficiently now that there's a bit of play in this PCB, so that's good. So I can find the threads in these, because they're just plastic threads, they don't have proper inserts, and these are just screws, but that fits fine. So I think that's about all I'm going to do now. The next thing I'm going to do is I'm going to put the relays in, but I only have these at the moment, and as I say, I think these are too high. In fact, I could just check that. Yes, I've got a feeling that's going to be too high. Let's get the lid. Yeah, I don't think that lid's going to go on there with those things sticking up at that height. So it's a nice idea having these relays with the spade connectors on the top, but I think I'm going to have to use the other relays, and they haven't turned up yet. But the relays will go in. I'll put 12 volts on this, and the relays should then immediately pull in because the driver transistors have their bases pulled up to 12 volts through a resistor. So that'll be the first thing I do. Then I might start building some clock circuitry here using the CMOS CD4060. I've got the crystals, I've got the capacitors, I've got most of the parts, just waiting for the relays. That's what's holding me up now. So like I say, happy with my EVSE printed circuit boards. This project really has to be up and running by spring, because the whole point of this is that it's going to eventually track the solar output from the solar panels on my roof, and that's all going to start kicking in fairly soon, really, once we pass the the equinox in March. But anyway, for this video, happy with these boards. That's it for now, so cheerio.